Good morning, students. Now we are going to see the topic in thermal energy based is laser beam machining process. In last classes, we have seen about the EBM, which is nothing but electron beam machining process. Now we are going to see laser beam machining process, LBM. How the name framed. Recent research in solid-state physics have revealed a new device known as laser, which means light amplification by stimulated emission of radiation. It produces a powerful monochromatic collimated beam of light in which the waves are coherent. coherent. Like the electron beam, the laser beam is also used for drilling microholes up to 25 micrometer and for cutting very narrow slots with dimensional accuracy plus or minus 0.025 mm. It is very costly method and can be employed only when it is not feasible to machine in workpiece through other methods. Principle of laser beam production. Laser work on the principle of quantum theory of radiation. Consider an atom in the ground state or lower energy state E1. When the light radiation falls on the atom, it absorbs a photon of energy Hv and goes to the excited state E2. Normally, the atoms in the excited state will not stay there for a long time. It comes to the ground state by emitting a photon of energy E equal to Hv. Such emission takes place by one of the following two methods. Spontaneous emission. The atom in the excited state E2 returns to the ground state E1 by emitting this excess energy Hv spontaneously. This process is independent of external radiation. Spontaneous emission. Stimulated emission. In stimulated emission, a photon having energy E equal to the difference in energy between the two levels E2 and E1. Stimulated an atom in the highest state to make a transition to the lowest state with the creation of second photon as shown. Now we will study about the principle of a laser beam machine. In laser beam machining process, laser beam, a powerful monochromatic collimated beam of light, is focused on workpiece by means of lens to give extremely high energy density to melt and vaporize the work material. Construction and working of laser beam machining. The schematic arrangement of laser beam machining process is shown in figure. There are several types of lasers used for different purposes. Example, solid state laser, gas laser, liquid laser, and semiconductor laser. In general, only the solid state laser can provide the required power levels. The most commonly used solid state laser is ruby laser. It is the first successful laser achieved by Meyman in 1960. It consists of ruby rod surrounded by the flash tubes. This is the ruby rod surrounded by the flash surrounded by the flash tubes. Synthetic ruby consists of a crystal of aluminum oxide in which a few of aluminum atom are replaced by chromium atom. Chromium atoms have the property of observing green light. The end surfaces of the ruby rod is made reflective by mirrors. One end of the ruby rod is highly reflective and the other end is partially reflective. The flash tube is called the pump and it surrounds the ruby rod in the form of spiral as shown in figure. This tube is filled with xenon, argon or krypton gas. Since the ruby rod becomes less efficient at high temperatures, it is continuously cooled with water, air or liquid nitrogen. Since the laser beam has no effect on aluminum, the workpiece to be machined is placed on the aluminum work table. Now we are going to see the working principle of a laser beam machine. The xenon or argon gas present in the flash tube is fired by discharging a large capacitor through it. The electric power of 250 to 1000 watts may be needed for this operation. This optical energy, that is light energy from the flash tube, is passed into the ruby rod. The chromium atoms in the ruby rod are thus excited to high energy levels. The excited atoms are highly unstable in the higher energy levels and it emits energy photons when they return to the original levels. The emitted photons in the axis of ruby rod are allowed to pass back and forth millions of times in the ruby with help of mirror at the two ends. The emitted photons other than the axis will escape out of the rods. The chain reaction is started and a powerful current beam of red light is obtained. This powerful beam of red light goes out of the partially reflective mirror at one end of the ruby rod. This highly amplified beam of light is focused through a lens which converges into a chosen point on the workpiece. This high-intensity converged laser beam, when falls on the workpiece, melts and vaporizes the workpiece material. The laser head is transferred over the work material by manually adjusting the control panel, and an operator can visually inspect the machining processes. The actual profile is obtained from a linked mechanism made to copy the master drawing or actual profile placed on a nearby bench. This is the another schematic diagram how the laser beam machining focused on the workpiece. Accuracy of the laser beam machining. The laser beam is used for cutting and drilling. In order to achieve the best possible results in drilling, the material should be placed within a tolerance of 0 plus or minus 0.2 mm focal point. Laser material used in laser beam machining process. Many materials exhibited lasing action, but only a limited number is used in metal working. Solids, gases, and semiconductors can be used as a lasing materials. Solid state laser, ruby laser, the neodymium DBM doped yttrium, aluminum, garnet, NDYAG laser, and the neodymium doped glass laser ND-glass are example of a solid state laser. The most commonly used solid state laser is ruby laser. Gas laser. The main advantages of a gas laser is it can be operated continuously. The gas laser produces exponentially a high monochromaticity and high stability of frequency. The output of the laser can be changed to a certain available wavelength. So the gas laser are widely used in industries. Example, carbon dioxide laser, helium neon, which is called HE-NE laser. Third one is semiconductor laser. Lasing action can also be produced in semiconductor. The most compact type of laser is semiconductor laser. It is also known as injection laser. In its simplest form, the diode laser consists of a PN junction doped in a single crystal of a suitable semiconductor. Example, gallium arsenide. Processing with lasers. Processing with lasers. It can be focused to maximum intensity or to minimum intensity as needed. Cutting process characteristics. Metal removal rate is maximum to minimum. Second point, in special characteristics of laser beam, it can be moved rapidly on the workpiece. In cutting process characteristics, cutting of complex shapes. Third point, it is projected on the workpiece at particular distance from the lens. Special characteristics of laser. Cutting process characteristics, remote cutting over long standoff distance. Dedicated to an online process. Rerouting is not necessary. Power is shared on a job. Two or more cuts simultaneously. Machining application of laser. A laser has a wide range of machining applications. Laser in metal cutting. A laser beam can be used for cutting metals, plastics, ceramics, textiles, clothes, and even glasses when its surface is coated with radiation absorbing materials such as carbon. Normally, laser cutting starts by drilling a hole through the workpiece, then moving along a predetermined path of a shape to be cutted. Steel, titanium, nickel, and plastic can be cut easily by using laser beam. But cutting of aluminum, metals, and copper is very difficult. Since these metals tends to absorb the applied heat, the cutting speed of the laser depends on the material being cut, its thickness, frequency, physical characteristics, and the output power of the laser beam. Laser in drilling. Laser drilling was one of the first practical application of laser technology in industry, and the demand for laser drilling is increasing. Hole drilling by laser is a process of melting and vaporizing unwanted materials by means of narrow pulsed laser operating at 3 to 95 pulses per second. Due to melting and vaporizing process, high accuracy is not possible in laser drilling. So laser drilling is not suited for deep hole drilling and for producing perfect cylindrical holes. Laser drilling is used in watch jewels, diamonds, dies, and other machining parts for various industries where a particular high level of a precision is not demanded. Laser drilling is used in aircraft turbines industries to make holes for air blade, air cooling, or passage of other fluid. It is also used for making holes in hypodermic needles, automotive fuel plates, various lubrication devices, holes in tungsten carbide tool plates, holes in baby bottle nipples, relief holes in pressure plugs, etc. Laser in welding. In this process, a laser beam is focused on spot where the two parts are to be welded. Laser beam welding requires more precise control of the input laser power than in a case of drilling. Laser welding is especially useful when it is essential to control the size of the heat affected zone, to reduce the roughness of the welded surface, and to eliminate the mechanical effects. It is generally used for welding multi-layer materials. There are two different types of laser welding. They are conducting limited welding, deep penetration welding, laser of surface treatment. These saw teeth Valve wear pads and cylindrical liners can be strengthened by using laser beam. The laser is used to deposit a thin layer of a cobalt alloy on the turbine blades, strode contact areas. Argon gases is used for shielding during deposition of the cobalt alloy and for cooling purpose. By using laser, a thin ceramic coating is applied on a metal surface for heat and wear resistance. Other applications are sheet metal trimming, blanking, resistor trimming. Advantages. Before that, we will see the characteristics. Metal removal techniques. Heating, melting, and vaporization of a material by using high intensity of laser beam. Work material. All material except those having high thermal conductivity and high reflectivity. Tool. Laser beam of wavelength range 0.3 to 0.6 microns. Power density 10 power 7 watts per mm square. Output energy laser 20 joules. Material removal rate 6 mm cube per minute. Pulse duration 1 millisecond. Dimensional accuracy plus or minus 0.025 mm. Medium atmosphere efficiency 10 to 15%. Specific power consumption 1000 watts per mm cube per minute. Next, we will see the advantages. Machining of any material including non-metal is possible. Micro-sized holes can be machined. Soft materials like rubber and plastics can be machined. Unlike conventional machining, there is no direct contact between tool and workpiece. There is no tool wear. Laser beam can be sent to long distance without diffraction. It can also be focused at one point, thereby generating large amount of heat. Process of the material does not affect the process. Dissimilar material can be easily welded. Heat affected zone is small around the machined surface. Beam configuration and size of exposed area can be easily controlled. Deep holes of very short diameter can be drilled by using unidirectional multiple pulses. Disadvantages. Initial investment is high. Operating cost is also quite high. Highly skilled operator are needed. Rate of production is low. Possibility of machining only thin sections and where a very small amount of metal removal is involved. Safety procedures to be followed strictly. Overall efficiency is extremely low, 10 to 15%. Some materials like fiberglass, reinforced material, phenolics, etc. cannot be machined by laser as these materials burn, char and bubbles. Life of flash lamp is short. The machined hole is not rounded and straight. Thank you.